Welcome back, Cloud Architects. By now, you know how to deploy instances with apps on them. Now let's scale and load balance them for performance, high availability, and reach. At a high level, your load balancer and autoscaler should host front-end IPs and terminate traffic close to users, distribute load to multiple instances, deliver resilience so requests only go to healthy instances, and scale your service when you need more horsepower by adding instances. Instance-based load balancers like AWS are deployed as processes. They need time to scale and warm up during peak demand. In addition, AWS load balancing is bound to a VPC, so it doesn't provide a single global IP. If you want to set up global load balancing, you need to set up load balancers in each region and global Route 53 rules that send traffic to load balancers and back-end servers closest to users. If a region fails, DNS changes need time to propagate and traffic will be routed to another load balancer over the internet with egress charges. Google's software-defined load balancer is deployed as routing entries in over 50 POPs around the world. They front user applications with a single intelligent Anycast virtual IPs, or VIP, using a Google's software-defined network. This allows them to terminate user sessions at the edge before deciding where the nearest healthy instances are. If a region fails or back-end servers are at regional capacity, traffic is automatically rerouted to servers in the next closest region without using the internet or incurring egress charges. This provides much less latency with no load balancer warm-ups, less reliance on DNS, endpoints and back-end servers closer to users with lower egress charges. GCP and AWS provide autoscaling as a collection of VMs that are provisioned, monitored, and scaled according to a spin-up configuration, health check, and set of policies for creation and deletion. AWS calls the collection of VMs an autoscaling group, each VM a target, and the spin-up configuration a launch configuration. GCP calls the collection of VMs a managed instance group, each VM instance, and the spin-up configuration an instance template. GCP and AWS allow you to define instance machine type, disk image, zone, startup scripts, and base names. Note that you can specify numbers of instances or adjust to conditions such as CPU, disk, and network use or custom metrics from monitoring tools such as CloudWatch or Stackdriver. AWS also provides scheduling and step adjustments to reduce spin-up wait time, but GCE offers faster spin-ups that make these unnecessary. And AWS offers hooks for extra tasks during boot up and shutdown, but startup and shutdown scripts can do the same. Then they can be put behind load balancers in one or more groups, each running their own applications or services. For details, see the link here. There are a number of features in load balancing. Requests can be in HTTP, TCP, or UDP. They can come from the internet or internally. You can put the load balancer behind a single IP and a security group to limit client access. They support health checks and session affinity. In addition, Google's HTTP load balancer and Amazon's application load balancer support path-based routing to microservices, so we'll focus on them.